get this recorded. And I'm putting, I think I told you I got 3 sections of this class. So I've already completed like the first week because it was Tuesday to Monday. So I put up the 2 best ones in my YouTube account. But you should be able to also review yours through the Zoom recordings if you want to. So basically finished chapter 1. So I want to see if we got any questions because we got plenty of time. And I don't want to rush things, so I want to make sure you got all the questions you need answered. All right, so I'm going to put in the people's. Let's see, this class has got a lot of people in it, doesn't it? Not too many. I'm going to put in the people I see here. Wait a minute, this is the wrong class. That's last night's class. Casey Cook, William, Alana Taylor, I see. Shantae Finch. Ramy Ebus. Michelle Williams. Let's see who else is out there. Evian Sullivan. Derek Williams. Chloe Foster. And then Christina says she was coming back. Anisha Cloud. I got Landon Ingraham. I got Ross. Okay. Let's see, is there any more people in here? A few more. Yeah, there's a lot of people. Let's see, Janisha Bell. Andy Wynn. Brittany Gordon. Victoria Gonzalez. Sophia New Power. Brittany Mista. Oh yeah, there's still more people in here. Christopher Weber. Walana Taylor, I already got. Zachary Gonzalez, I got. No. Courtney Butler. Timothy Mellows. All right, who is what is it? KJ Jameson? Is that
That's me,
Christina
Foster. Yeah,
okay.
Sorry. My
That's
other
all right.
computer, the internet wasn't working on it.
Okay.
So I had to log in, but
I saw your
login.
message, and that one said Christina, so I was kind of putting 2 and 2 together, but I wanted to make sure.
Yeah, that's me.
All right. So that's the last. Okay. What we'll do is like in a little bit later, I'll call the people that I didn't see yet. Because people sometimes, take a while to get here. All right. So as I said, we'd finished chapter 1 of the textbook, which, as I said, is kind of a review of basic math. And then from now on, chapter 2, for the most part, everything we're going to deal with, deals with algebraic type stuff, which means basically you got X's and Y's and stuff in it, variables. All right. So has anybody got any questions about anything? Anything you want to see? Let me go ahead and see. Just kind of briefly review everything that we looked at so far. All right. All right. Let me share this screen. Okay, so this right here, the worksheet 1.3, that was where we worked adding and subtracting. And when you're dealing with fractions, you've either got a common denominator, which is the easy ones because you can just take the common denominator, write it once, and then put the operation in between the two fractions in the numerator and then simplify. If they're different, then you got to have some method in order to find the LCD. I like a factoring tree because it kind of breaks it down and it's hard to miss if you do it that way. All right, that was that one. Let's see, we'll come back to 1.4, but we'll look at 1.5 and 1.56. This is where we did the adding and subtracting. And the rules are basically if they're the same sign, then, and that's what these are. Just because of the subtraction sign, you could write this with or without the plus sign. You could put -7 plus and in parentheses -12, but it's more common to see it like this. But this is essentially adding or subtracting. The properties work the same. So if you got the same sign, no matter whether it's two negatives or two positives, you add or subtract, you add and you do the addition, and then you take the common sign. If they're both positive, it would be a positive, but if in this case they're both negative, so it's going to be a -19. Now, if the two signs are different, positive and negative or negative and positive, it doesn't matter about the order. Then this is where we take the difference, which is a fancy word for saying subtract, and then take the sign of the one that's got the larger absolute value. Okay? That's the two rules for adding and subtracting. Now, just one thing to mention again. If we subtract a negative, in other words, if we take the difference of a positive number and a negative number, then we end up adding because the negative of a negative is a positive. And I think I showed you that little thing with the thermometer, how when you take the difference, when you go down below the zero, then you end up adding that amount to show the total distance traveled. All right, so let's see. The next thing was the multiplication and division. Multiplication and division, really pretty easy rules. If both signs match, either two positives or two negatives, then the outcome is positive. And this is whether you have a multiplication or a division. All right. Multiplication and division are really the same procedure. It's just, as we've seen already, and we'll see again real briefly, that division is multiplication by the reciprocal. So the rules are the same. If they're mixed signs, now here we got mixed signs, a positive and a negative, so the outcome is negative 54. And it doesn't matter if it would have been the 9 that was negative and the 6 positive, same thing, negative outcome of 54. Two of the same sign, so whether it was two negatives or two positives, we come out with a positive, both multiplication and division. Now this one right here, there's three negative signs, but remember, we're always doing two at a time when we use these rules. So negative 3 times negative 2 is positive 6. Positive 6 times negative 5 gives us negative 30. You can kind of also, that there's three negative numbers. So if you got three negative numbers being multiplied, you can kind of just know that the output is going to be negative and then just do the multiplication. And the same thing here for number 4 and number 6. It doesn't matter whether it's the divisor, which is the new denominator, or the dividend, which is the top. It doesn't matter which one is negative. As long as one of them is negative, then the quotient is negative. And just if you got questions, just let me know as I'm going through. I'm just trying to recap just so we can see what we should know by now. All right. Now, I think the next thing was the order of operations. It was 1.4, but they had it in the calendar as coming last. Order of operations, remember, anything with parentheses, in other words, any parentheses that have something to do inside of it, then we work on that first. Then once we've got that, then we go to any exponents and handle those. And then we go to multiplication and division left to right as they occur. That's important because that PMDAS kind of gives the impression that you do multiplication first and then do division, but it's a multiplication and division, so they're the same operation. Then you go left to right as they occur. There's always one problem out there that if you don't do it like that, you'll end up in a little bit of a problem if you don't watch that. But that cures all when you do that. We did some substitutions. Now, like I said, as we're starting to see how kind of algebra plays in all this, and when you replace the variables by a particular number, so x gets replaced with 6 and y gets replaced with 2, then you just go through and do the math. It was 2 squared, so that ends up being 4 down there. That gets handled first. Then we do the multiplication. 3 times 6 is 18. 2 times 4 is negative 8. 18 minus 8 is 10. And then we did some translating. It's important to be able to translate in order, okay? The order matters because when it says, well, the order matters specifically when you're talking about a difference. And that's one of the things I'm going to show you here in a second. When we get to the next section. All right. So that's basically what we've looked at. Doing order of operations is a broad scope of what's going on using addition, subtraction, multiplication, division. Let's see. I'll open this. All right. So 2.1, like I said, that's kind of where we officially get into the operations that involve now bringing in variables. Okay, so let's talk a little bit about this. I got a nice little visual here because we're going to talk about like terms, what that means when we're talking about algebraic expressions, which is what these are. Anytime I say this, the differentiation between math and algebra is just that when we get into algebra, we're talking about variables. All right. So notice that in that first row up at the top, there are some terms that are surrounded by a green box, two that are surrounded by a blue circle, and then one by itself, all lonesome. That's like a purple or something like that. So we got 5 different terms here. Well, what is like terms? Well, the best way to describe it is a like term is when the variable part is the same. The variable part is the same. So notice on the green up here that we've got 4x squared, and then this right here is 1x squared. It's just that if we just got a 1, we don't have to put in the 1. It's understood that if you just got an x squared, that it's 1x squared. So those two are like because the variable part is exactly the same. So that means then we can combine those like terms by essentially just adding up the 4 and the 1 to give us 5x squared. You know, you can think of these as whatever you wanted to. They just have to be alike. You know, if these are, you know, oranges or limes, let's say, because it's green, you got 4 of them over here and you got 1 of them over there. You combine them, you got 5 of them. Now, the other 2 that are alike are the xy terms, both the 3xy in blue circle and the 7xy, which is also in a blue circle. They have that exact same variable part, xy. Now, if one of them had xy and the other one had xy squared, then they would not be the same. The variable part has to be exactly alike in terms of what we call the exponent. This right here is essentially saying 3x to the 1, y to the 1. But again, it's the base case, so we don't really put that down there. So the 2 that are alike are the 3xy and the 7xy, 3 and 7. Even in the universe now, just like it did in chapter 1, we just add those up. They're both positive. So we take the common sign of positive 10. 10xy. Now the 14x negative was all by itself, so it's just going to come along and attach there. So the one with 5 terms up here on the first row can collapse into the one here on the second row. All right, any questions about how those like terms work? All right, so let's go back to the sheet. All right. Okay, so here we got a pretty basic example on number 1, example 1. It's just got 2 terms, and we just got to decide, are they alike? And yes, they tell us they're alike. 5x and 6x are exactly alike because they've all just got that same variable part of x. So these are like terms, so we can add up the 5 and the 6 to get 11, and then we carry along its term with it. number 2. Number 2, it's got two different terms hidden in there. You got a 5x and a 6x negative, and then you got a negative 7y and a negative 4y. So we're going to use those two rules about adding and subtracting. We're using the one where we have the common sign because the negative 7 and the negative 4 are both y's. So we're going to add those. Negative 7 and negative 4 is negative 11y. Now, the first one, remember, we got a positive 5 and a negative 6, so that are the opposite sign. So we take the difference, which is 1, and then we take the negative as its sign because that one is the larger absolute value. So negative x minus 11y. All right, questions? Okay, so sometimes you're not going to be able to simplify until you kind of take care of a little bit of housekeeping first. This housekeeping we need to take care of here is there's a negative 2 in front of parentheses there, and parentheses mean two things. They could mean do something inside of here, here's some operation inside of here, but it also means multiplication. If you have something that's smack up dab next to it, which in this case is a negative 2 right next to the parentheses, then that means we got to multiply everything inside of that parentheses with the negative 2. So they show us here with a little arrow, it's negative 2 times 3x. So that's negative 2 times positive 3 is negative 6. And there's just one x that's going to come on down. Negative 2 times 8 positive is negative 16. Now we're in a similar situation as we up here, that we've got all the terms ready to be combined. We can't do any combination here because on that
she's the consonants left often, so 20% of the time consonant.
All right, I thought somebody had a question. I guess something else came on. Okay. So now we've got two different terms here. We got a 12 and a negative 16, and those are just regular numbers. There is no x, but as we're going to find out when we start talking a little bit more about exponents.
Classes with her peers.
We're going to find out that those are like terms too. The numbers, just plain old numbers without any variable part, are also alike. So the 12 and the negative 16, they're opposite signs. So the difference between 12 and 16 is 4, and the 16 is the larger absolute value. So we take negative 4 there. On the x's, negative 6x and negative x. So that's negative 6 and negative 1x, like terms and also like signs. So 6 and 1 is 7, both negative. So it's negative 7x, negative 4. All right. So anybody got any questions so far? Let me see who else showed up. Okay. Rashawn Bluefield looks like she's here. Is Bruce out there, Hughes? Bruce Hughes out there? I don't see him. Okay. Hassani Matthews out there?
Here.
All right. What? Okay, yeah, I see you there. I heard you, but I wanted to just say, let's say, Tyrone Sutherland. Tyrone Sutherland. Okay. Don't say. Arnisha Taylor out there. Okay, doesn't look like. Denasia Van Fron, she was here last time, remember? Denasia, not out there. All right, I think that's everybody. If I didn't call you, it means I saw you on there. So the only ones I got absent are Bruce Hughes, Tyrone Sutherland, Ornisha Taylor, and Denasia Van Fron. If you see any of those show up, y'all can yell about to me. All right. All right. Anybody got any questions about anything? Y'all all set up in the My Math Lab? Because remember, that's important. I had put, and I got the calendar here, and I'm going to bring it up again. I'd made a little change because the due dates, the way that the department set them up, they put them all like right around the time that the test is due. And I just wanted to put this little note in here that I recommend completing the My Math Lab assignments within 2 days of covering in the class. Okay. All right. So, in other words, to save yourself having a whole bunch to do on the 7th, which is like a Sunday, I think, these ones that we looked at last week, you should hopefully got the homework done on there. It's not going to hurt if you haven't, but like I said, catch up as soon as you can, because like I said, when we get down here to the 7th, those are all going to come due, everything from here on down. And then at the beginning, well, right around at the tail end of the first week of February, we'll be having our first test. I'll talk to you a little bit about that. It's probably not going to be on just that one day, because I want to give you a little extra time to work with. We'll see how we're going to do that. All right. So any questions so far? Remember, if if you haven't been in it, this is all there is to it. You go to course materials. And then oh, it's awful slow. It'll come up eventually here. But anyway, and you click launch courseware, and then when you do that, the little orange, I think it's orange, isn't it? The little orange button comes up. All right, and then the first time you press it, it's going to go through the registration process. It may be able to figure out who you are, but if you've not taken any My Math Lab classes, then most likely you're going to have to register for the first time. And then once you register, then when you click on this from now on, it'll take you into the homework, or not just the homework, but everything. And just remember, if you've taken this class before, when you do that, if it doesn't figure it out, make sure you go into your old account, because otherwise you could end up paying for this again. Because if you register in a new account, they got no idea that that's the same person. All right. So just kind of show you, there was something I was going to change over here, but everything's running so darn slow. In the My Math Lab, nothing else, everything else is going all right. So when you go into home, you'll see the dates. I would recommend just going straight into assignments, because once you do that, you see them in order, and you can see they're clickable. When they're blue like that, they're clickable. I just noticed that these had a weird date. I'm going to change those to like the 6th or something. These video lectures. Probably what I'm going to do is I'm going to put that into what they call the participation section of the grade book. And then you can just click on those and if you want to see them, that's fine. It's just, but I don't think to get credit for them, you have to actually sit there and look at them. But I'm going to change those dates.
You could, it's unlimited tries on homework, huh?
Yes. So in other words, when you go through problem to problem, I think you get 3 tries. So, for example, you get 3 tries and then it's going to mark it wrong. But once you go through and do everything else and then submit it, you can go back in and do the assignment again. Like that you can do. So yeah, in a sense, you got unlimited tries on the homework. So you should be able to get 100 for the most part, but you only got 3 tries each attempt. Now, for quizzes, I think there's like 5 attempts, but that should be enough to get you through and be able to get 100 on each of those too, if you're that dedicated. And then with the regular tests, which are the ones that are coded in green, those are only going to have 1 attempt. But as I said, here, let's just say I get one of these wrong. See, it's going to give me a similar question if I get it wrong. I think what happens if I do it 3 times? I know there's used to be a 3-time thing.
It's only going to be 2 on questions like that.
Yeah, you're right. So this one looks like it's letting you go through and do it till you get it right too. Well, anyway, but there's more than 1 attempt. I know that. And technically it should be infinite attempts. I thought that there was only 3, but the point of these things, they're not really
if it's multiple choice, like more than 1 answer choice or more than 2 answer choices, then it'll give you 3 tries. Or if you have to type in the answer.
well, like if you got to type in the answer, I think that's the ones I'm really thinking that are ones that do the 3. But after you get it, if it goes wrong, then what happens is you go through the rest of the assignment, but then you can go back and once you see your score, you can, I think they say, do you want to raise up your score? Do you want to review or something like that? See, like for this one, 1, 2, 3, 4, 5, 6, 7, 8. So let's just say, I want to deliberately get it wrong and see what happens. Yeah, this is one of the ones where they do the 3 attempts. See, because I'm going to deliberately get it wrong. It's supposed to be 1/8. See now, well, now it's letting me do similar problems. So even with that, you can just keep on going. So they got it built in. So you should be able to get unlimited attempts. All right. So, okay. I know what I was going to do once. Thinking I was going to change the dates on those videos. Because I don't know why. They got them like at the end of the semester. So any other questions about this system right here or anything with Canvas and getting to it while we're at it? All right, let me change this while I'm thinking about it. So how long is that till we got, so that's about, is next week February?
Yeah.
So then next week will be the first week of February. So we'll be able to finish through all of chapter 2. And then at the beginning of the next following week, the second week of February, is the test. So we got this week and this week to work on chapter 2, and then the test is going to be done right in here. I'll probably give you like 3 days, and you just have to finish it before we start class on the 11th. But we'll talk about that when we get there. All right. So while I'm thinking of this, I'm going to change this. Because these video lectures, they have a date in May, and it doesn't make any sense. All right, so you okay? Because we're going to go back now to that chapter 2 stuff. All right. I'm trying to figure out who it is that's making the noise. I'm going to mute him. Because whenever you got that, there we go. All right, so no questions about this while we're over here? All right, let me hit the update, and then we'll go back to that. All right, so chapter 2. There we go. All right, so what we're going to do is I want to task you to do these. I was going to try the polling thing just to see how it works. No, it's telling me something's wrong again. I got it working in another class, and now maybe it'll work anyway. All right, so on that first one, all right. All right, see if you can see that poll. If you can't see it, we'll just work on it anyway. But I don't know. I had it working the other day, and then now it's just acting strange. It gave me an error.
I mean, I
said,
can see it on your screen, but I
yeah, I
can't
know. I
like
saw it on there too, but
survey.
it's supposed to pop up. Did I not click on
Is that
something?
supposed to be in the chat or?
It's supposed to just be a pop-up.
Is it because you're still sharing your screen with us?
No, I don't think that's it. I can turn that off and see. But when I first turned this on, it said that I couldn't enter in because I'm logged in on another screen, which I said I got 2 computers here. so that way I can see what you're seeing. And but I did this the other day, I think, yeah, yesterday, and it was working fine. All right. Well, we'll just go through and do it the way I've been doing it. I'll figure it out. All right. So what's the answer on number 4? All right. We'll just work it out, and then we'll try to do 1 through 4. All right. That might take us up to our little break. All right. And then we'll go through them in detail over there.
You said number 4, huh?
Do 1 through 4.
Oh, okay.
Yeah, all 4 on that top row. All right. Anybody got any answers on any of these?
11x.
11x.
Okay. What about number 12? I mean, number 2.
14y,
14y. Good. That sounds good. 3.
negative 6x,
Negative 6x.
Okay. What about 4?
Negative 2x plus
Plus what?
y.
No. Okay. That sounds right. All right. Let's go through them. I think I've already got them written on here. All right. Yeah, I got them down here at the bottom. So, all right. So on number 1, those 2 are like terms. We got a 4x plus a 7x, so it's 11x. Now, another way of looking at this, it might be kind of look a little bit convoluted, but you can do it sort of like this, and you get the idea about why it's happening. 4 plus 7x, because it's sort of like how we're dealing with, how we dealt with the fractions that have the same denominator. Well, it's the same idea, because if they got the same denominator, then you're going to use that denominator only once to get the final, sum. So what we're doing is we're taking 4 plus 7x. 4 plus 7 is 11x. Now, certainly, if you can just tell that they're the same, you can just jump from here to here, no harm. See this right here? This is 15 minus 1. All right, that's what that is. When we have a negative y, that means a negative 1y. So 15 minus 1y is what? 14y. Okay? Now for the next one here, they're both like terms. So it's 12, take away 18. Positive 12, negative 18. So take the difference, which is 6. The 18 is the larger absolute value, so that's the sign we use. You can also think about it. You pay $12, and then you also get another debt of $18. Well, you're still in the hole by $6, and that's what the negative sign means. It means you owe that much in a sense. Thinking about these things in money can cure a lot of math problems, because people tend to think of it as abstract and they're afraid to think about it. But since money is kind of personal to people and important, that's one way of looking at negative and positive numbers. Negative being debt, you know, positive being, you know, ahead of the game, you know. So if you think of it like that, oftentimes you can kind of get around the clouding that the math tends to create. So 10 positive, negative 12, these are both x's. So 10 take away 12 is negative 2x, because they're both x terms. All right. Now we got a negative 3y and a plus 4y, both y terms, but we got a negative 3, positive 4. So combine those. If we got a bill for $3 and we got $4 to our name, well, we're $1 ahead, 1y ahead. So 10 minus 12 is negative 2x, and then it's plus y. Any questions about those? For some reason, I'm wondering if I had, since all of my first class, I might not have seen these, but I was going to let me go through these things. These would be the last little section in 1.4. It was the last thing. But one of the things I want to just point out about the terms, like a number refers to a variable. All right. A number refers to a variable. Now, there's different words you're going to see. You're going to say added to, increased, more than. Those are all things that denote addition. So if we have a number, well, that translates as a variable. X is fine. Increased by 7. So the way we would write that, you know, functionally speaking, mathematically speaking, is x plus 7. Now, remember, division and a multiplication are really the same operations, but it's important to realize that the order matters. In other words, 12 divided by 4 would be different than 4 divided by 12. So the one that comes first and second matters. Same thing with addition and subtraction. All right. Addition and subtraction order matters because when we see something like that, it says 8 less than a number. So even though the 8 less than comes first, it's implying that it's 8 less than that variable that we're going to use, x. On the worksheet, if you're reading the actual worksheet that was in your Canvas, there was a little number right here that was there inadvertently, so that's why it's wiped out there. I don't know what that was left over from. It was from something that got put there by mistake. All right. Now, so 8 less than the number means that we got the number minus 8. So the order that it's written in is not the order that we want to put it in, mathematically speaking. Because it might be tempting to put 8 minus x, but that's not the same thing. It's saying 8 less than a number. Now, when you see these things like sum, product, difference, and quotient, those are buzzwords for sum is addition, difference is subtraction, and then product is multiplication, and quotient is division. So when it says twice the sum, and then it gives you numbers that are going to be involved in the sum, that denotes, usually when you see the things sum and product and quotient and difference, it means that you're going to have to open up a parentheses and put that operation in there. Because what this is saying is twice the sum. Well, what is the sum? Well, The sum is what's inside of the parentheses, x plus 4. The sum of a number, x, and 4. And then this says is, now is the one thing that's going to translate to equal sign in mathematics. You might also see the term equals, but is translates to equals. All right. So 2 times x plus 4 is twice the number. So the sum of a number and 4, here's the sum, x plus 4 times 2 is equals to twice the number. So that's what we would call an equation there on that one. The first two were just expressions. Now this one, the product, remember, that just means we're going to multiply two things here. And what are we going to multiply? Twice a number. Remember, we don't know what a number is. That's why it's a variable. Twice a number is 2x. And the other part of the product is 7. The product of twice a number and 7 is 12. Now, in this case, since we got 2x and then being multiplied by 7, we can go ahead and simplify a little bit further as 14x is 12. Okay, I wanted to make sure that we had looked at those because I don't know. Like I said, I probably should keep notes because we got, like I said, I got 3 of these classes and it's hard to remember. Usually if I just got 2, I can easily remember what it was I covered, but all right. I think this is the first time I had 3 sections of the same course. All right. So I tell you what, let's go ahead and take a little break. And then we're going to come back and look at these if you want to. Go ahead and all right. So before we did Bruce Hughes ever come in? Tyrone Sutherland, Anisha Taylor, or Denasia Vampron? Any of those ever come in? All right. Everybody else was here. All right. So let's take let's see. I'm getting a student here that says they gotten kicked out and they can't get back in.
That was
What we were doing. Okay, so let's look at this next row. This next row, there'll be a little bit more difficult because it's like the example 3 that you got to, before you can simplify, and the simplification, usually the last step of simplification is collecting your like terms. So oftentimes you can't do that until you do a multiplication, some kind of a parentheses, or what we call a distribution. So y'all work on these 5 through 8, and then when you get an answer, yell it out. I'm gonna do them again. I already got them worked on that other sheet, but I'm gonna work them again here. So 2 through 8.
I got got 11x minus 12 for number 5.
11x minus 12. That sounds good. We'll work that in a bit. Show it on the next one. 6. And just remember, one of the biggest things that students forget about is on distribution. You got to multiply the number in front of the parentheses times everything in the parentheses. So like number 6, you're multiplying the -4 times the x and the -4 times the -5. Okay. Sign goes with it.
Can you repeat that, please?
Oftentimes what happens with this kind of a thing right here, this is what we call a distribution when we multiply. And we got a 2 in front of a parentheses, and then we got the 4 minus x in there. Well, when you multiply that, you got to multiply both of those things. So 2 gets multiplied times 4x, and 2 gets multiplied times -6. Over here, the -4 gets multiplied times the x, and the -4 gets multiplied times the -5. All right. One of the big things that happens is students will write this as -4x minus 20, but it's -4 times -5. So it's going to be a positive 20. So watch that. That's a big mistake that I see quite often, because you got to follow through. You got to multiply both of them.
Wait.
Well, see the -4? It's in front of the parentheses. So that means it's multiplying both of those terms. It's -4 times x, -4 times -5. Okay. This one's similar.
So a negative plus a negative is a negative still?
But no, well, if we were adding, but now if you're asking about this one, it's not, that's not adding, that's -4 times -5. Yeah, so that's positive. But those are
adding
two,
is going to still be a negative.
Yeah, that's two rules that are really close related, but they're, that they overlap. That if you got two negatives and you add them, you end up with negatives. Whereas if you got two negatives and you multiply them, you got a positive.
What's the answer for number 5 again?
Did anybody say? Oh, I think it said 11x minus 12.
Okay, that's what I got too.
All right, so let's go through number 8, and then we'll go over to the board and.
You say 8?
Yeah, through 8.
A number times a variable will be the number and the variable.
Yeah, just right. You just put them next to one another. Now, if the variable has a number in front of it, you multiply the number times the number and then keep the variable.
All right.
All right. So what happened with number 6? Did anybody get that?
I got -4 plus 32.
What is it?
-4x plus 32.
-4x plus 32. Okay. All right. And when somebody gets number 8, we'll go over to the board. So what is number 7? Anybody got it?
-16 minus 7x.
All right. That sounds good. All right. So 7 and 8. Anybody come up with those?
I think she just said the answer for 7.
Oh, yeah. What about 8? I'm sorry. Yeah, I heard 7.
I got
Negative
negative 10x minus 13.
All right, that sounds right. All right, let's go just look at them step by step here. You know what? I'm gonna try the board on this thing. Is there's a board on?
How did you get negative 10x?
Well, I'm gonna show you, but when we get to it, I was just gonna try to I wanted to try this board on here. See if it's any good. All right, so the first one. Okay. All right, so the first one was 5 is you know what, I can thought of something. All right. Okay, is that number do I have it written out right? Number 5?
Yeah.
Okay. So now I'm going to go ahead and just take it step by step. So it's 2 times 4x. I'm going to just put in a couple of little steps here just to show you what's going on. See that? How I'm multiplying both of those? That's what it means to distribute. Okay. It's 2 times 4x, and then 2 times the negative 6. This is a right nice little board. I'm surprised I like it better than the Google board. All right, so 2 times 4x is 8x, and then this is negative 12 plus 3x. These two are only alike. So that's 8 plus 3 is 11x. And then 1, what we call a constant term. All right. Questions about that? All right. So, all right. That's number 6, correct? There wasn't anything after it, was it?
No, I think
Okay. All right. So the 12 is coming along for the ride because we got to do the multiplication part first. So it's negative 4. Terrible negative 4. times x. I'm just going to set it next to it. And then -4, and this is the part I was telling you I was trying to harp on, because it's very difficult and very easy to leave off one of the negative signs. But you got to realize this is a -4 here, and you're multiplying it times a -5. Plus 20. Okay. Negative times negative is positive. The way it works with multiplication, like signs in multiplication give you a positive. All right. So now these two are the same. So I'll just put the variable first. And then that's the 32. Any questions about that one?
Does moving the variable to the front work like every time, so long as you move the
Well,
negative? To the
Yeah,
front
and
too?
this is, I mean, basically the rule of mathematics. It's something called the commutative property of addition. So 4 plus 7 is equal to 7 plus 4. But what you're going to find out, I'm not sure exactly where it comes out. I know it'll start coming up soon. But generally speaking, the way that you order these, what they call polynomials. Well, this one's just a binomial where you got an x term and a number term. But when you start getting x squareds and stuff like that, usually the correct way to write it, I mean, if you had 32 minus 4x, I would be happy as all everything if you got to that point. But generally, the formal way is you start with on the left with the highest power of a variable you got, which in this case is this one. So like if you had an x squared term, then that would go, here, further to the left. And then you would go down in terms of powers of x. But yeah, so yeah, but if 32 minus 4x is the same thing as minus 4x plus 32. As long as you got the sign, take the sign with the term, you're all right. Any questions about that one? All right, let's put out number 7. All right, so this has got to be handled first because that's a multiplication, so we want to handle that first in terms of order of operations. All right, you can't really do anything inside the parentheses because those are not like terms. If there were two like terms in there, you could add those up first inside the parentheses. But there's nothing to be done inside the parentheses, so that's why we're jumping to multiplication. If we knew what x was, we could fill in x here, and then we would add these or multiply the 5 times whatever x was, and then add it to 6, and then multiply. But like I said, there's nothing to be done inside of that parentheses, so that's why we go into multiplication. So it's 2, and I'm just going to write out the baby steps because this is something very difficult to see. I'll even make mistakes with this if I, not paying attention. So it's negative 3 times 5x and negative 3 times 6. Plus 8x. All right, so now let's do a little bit of simplification. The 2's by itself, nothing that we can do with that yet. Here's the multiplication, the negative 15x minus 18 plus 8x. All right, these two are alike. These two are alike. So what do we got? I'm going to put the x term first. 15 negative and a positive 8. So the difference is 7 negative x.
So does it always have to come first like that?
No. If you're asked, to write it in descending order, because later on we're going to find out that generally speaking, that's what they call standard form, is that for them to be ordered, the highest variable first. But here, it doesn't really matter, okay, as long as you just come up with the right terms. But, generally speaking, like these two things are equal. So those two things are equal. That and this are the same thing. As a matter of fact, you can even argue that this is a little bit more simplified because it uses a one less sign. You don't need the plus sign in there. But like I said, is conventionally speaking, we're just looking at binomials now, but generally speaking, is you order highest variable to the lowest, down to the number term being last. So that's why I do that.
Excuse me.
Mm-hmm.
Can we do the test on our own time, but we got to do it as like a class on a certain day?
Well, I think what I'm going to do is I'm going to give you like 3 days. Like it'll open up maybe on a Sunday, and then it'll be opening up on Monday, and then the last day it's open will be the Tuesday, and then we'll use that day to answer any questions that people have. Because oftentimes what ends up happening, even if you give people 3 days, most people will wait until the last day to do it. Just my experience. Not always, but usually. So instead of, because it says review and then the test, but I'm not going to give the test in class because just because what am I going to be doing? Just sitting here watching y'all take the test?
Right.
We're going to have certain tests, the midterm and the final, that are proctored. So what we're going to do before, it'd be like test 3, I think it is. We'll have a trial run with the proctoring system. So just so you won't have any surprises come to the midterm. And what it does is it's proctor you. You don't have to make an appointment or anything. What you do is you just create a ProctorU account, and then you go back and you go to your test in My Math Lab, and then you log into the ProctorU account. And what it does is it records you, and it's audio recording and video recording of you taking the test. So you show your ID, and then they watch you to make sure you're not bringing in somebody to help you, kind of thing.
Does the test come with like a built-in calculator like the homework does?
It should. Is there one built in?
To the My Math Lab? Yeah, there is.
I never
When you
really
solve.
noticed. They might have put that in recently. I know that in another system we do, it's called Alex, which is 120 and 203. They've got a calculator wheel down there, and I thought that was neat. But let's see. I want to see, so I just know for sure, because I didn't know it had one. It used to not have one, but they must have put it in there recently.
Yeah, it's underneath the little help tab, like when you're
Oh,
going
okay.
through
So with like the
each problem. Yeah, it's
so
like
let's just say like for this one is this. Sometimes if you click on the problem, it's going to be one that's like a definition, and there won't be any helps. But I just want to see the calculator. I think I may have seen it, and I just forgot about it. But so in here, no. Oh, question help. That's it. So what calculator is it? Yeah, you can use that one. No problem. Like I said, the official one is the one that's listed on the syllabus. That TI2X thing. It's about $10. If you want to get that one, you can. You're not supposed to be able to use the other one, but I don't have any problem with you using this one.
so if our exams are in Respondus, though, we won't be able
It's
to
not.
like.
It's not Respondus.
Oh,
It's different. It's slightly different.
okay, but it still like
It's not
locks
locked.
down your.
It's not locked down.
Oh, okay. So you could have like a calculator on your computer or something, or like,
Well,
will
you
we
got
get in
this one.
trouble?
You got this
Yeah.
one.
Okay.
So I would say safe to use that one. If you're going out on a website, that's when it's getting to be a no. Okay.
Heard that.
So, and that's why too, you want to make sure you're showing the correct calculator. If you're didn't bring a calculator, you can use this one. But if you bring a calculator, it should be the official one. But that's the one that the handheld one you can buy it. The good thing about it is you can use that one in Math 120 if you take that. A lot of students have to take Math 120. And just to show you again, I'm going to show you if you want a physical calculator, make sure you get this one. If you don't have one, now that I know there's a calculator in my math lab, you're free to use that. Even if it's Respondus, that should still work. That little pop-up, that little calculator. But the official calculator, let's see, where's it at?
Will you put that in the chat, Mr. Cruz?
Yeah,
the name of the calculator.
Yeah, and I was just going to show you a video of it too. A visual of it, but I don't know why everything's taking so long. I guess I'm going to have to reboot this computer before morning. All right, where's it at? But see, it's called Proctor U Record. It's very similar to Respondus, but not the exact same thing. Well, it's in here. I'll get it. I need to get back to number 8 before I forget. All right, so I thought it was like right on the first page. I must have hopped right over it. Like I said, everything is acting quirky. All right, there's the first page. Yeah, that's right there. All right, so put it in the chat. And just to show you, like I said, it's probably about the cheapest calculator you can get. But the department is real particular about people using something different because the other calculators that look very similar will do things that they're, that you're being tested on. So that's why. But let's just look at that one. And I'll do the share again. So that's the one right there. Okay. So if you want a standalone calculator, you can do that. But as far as I'm concerned, that one in my math lab is fine. All right, so let's go back over and finish up number 8. I just want to finish up this section today. I'd like to get a little bit ahead too, if we can, just in case something happens. But anyway, back to the whiteboard. Okay, so number 8 was 2 times x minus 5 minus 3 times 4x plus 1. Okay, so I got it right, don't I? I wrote them down, so when I write things down, there's always a possibility I skip something, but I'm pretty sure that's
right.
Okay, so now we got 2 times x plus 2 times negative 5 minus 3 times 4x. It's going to end up being a negative. And then minus 3 times 1. So it's 2x minus 10 mismatch signs. Again, mismatch signs here. And then minus 3 times 1 is just minus 3. So these are alike. And these are alike. 2x positive, negative 12x. So that leaves negative 10x. And then negative 3 and negative 13. 3. Negative 10 and negative 3 is negative 13. All right. So we all on the same page now?
Yeah.
All right. So the last thing in here is something you just got to watch here. These kind of build on these where we had to distribute. But you got to realize something. Oops, I got to show you this. You know what? I wonder if I can copy and paste these over there. And make it. It didn't work. I may just have to go back. All right, I tell you what, I'm going to go on this little board because I did it over here. So let me stop the share and then just do the share on the screen. All right. So when it says subtract 3x plus 7, I'm going to erase these and rework them. Boy, this is just weird. It's like everything is just slowed down. All right. So when it says subtract 3x from 8x minus 5, it's important that we get this order right. Because remember, subtraction and division, the order matters. Because if you say subtract 3 from x, and this is kind of what we looked at over here, 8 less than a number. So if we subtract 3 from x, then even though the order is different, this is what is intended. This is x minus 3, which is subtracting 3 from x. But notice how the order is flipped around from the way that it's written in words. Therefore, on this right here, when it says subtract 3x plus 7 from 8x minus 5, we got to subtract from this. In other words, the first thing to put is 8x minus 5. And then we're going to subtract this. All right. Now, I'm going to steal a little bit of room and put this up here. All right. So the 8x minus 5 is just going to come along. And then we're subtracting a positive 3x, so that's negative 3x. And then we're subtracting the 7. So what we're doing is we're distributing that negative sign to each one of these terms that happen to be both be positive. Once we do that, then we just collect like terms like we've been doing. 8x and minus 3x is 5x. Negative 5 and negative 7 is negative 12. All right, now do me a favor and try this one right here. Sorry, number 10. We'll give you a minute or two on it while I go look for something. And then, oops, I'm sorry. I wanted to download this. I'll put it back on there in a second. I want to get this one. I'm thinking about it. The one for the next section. Chapter 2. Or chapter 2, section 2. So I'll put it back up there. So this is the one I want you to work on right there. Number 10. So set it up the way that it's intended to be set up from the words, and then simplify it. I'll come right back to it. I want to just download this thing. All right, so has anybody got that one set up or done?
Yeah.
What happened?
I wasn't okay.
All right. So how should this one be set up? How would we write it out mathematically? We can do it right here.
X take away 11, 9 is 9, X take away 2.
So what would we, I mean, in order to write it mathematically, whoops. So we're subtracting this from that. So x minus 11. And then from that, we're going to subtract 9x minus 2. You see that? So that subtraction there, that applies to because it's subtracting both of those terms. All right? It's going to affect both of them. So what's going to happen? It's going to be, and then we're going to subtract the 9x. It's positive, so it's just going to be tacking a negative sign on it. We're subtracting a negative 2, so what does that end up making it? Positive 2, right?
Right, because the signs are not alike.
Yes. Well, I was talking about on this one. I mean, when you take the, when you subtract 9x minus 2, you're subtracting positive 9x, so it makes it negative 9x. The negative of the negative 2 makes it positive 2. But yeah, then here, these are both different terms. I'm sorry, they're the same terms, but they're different signs. So positive x, negative 9 is negative 8x. And then negative 11 and plus 2. So the difference is negative 9. Is that right? All right, so any questions about all this? So can you still hear me?
Yeah.
All right, good. All right, so like terms. All right, so let's just talk about a little bit about this to finish out our time. I got about 15 minutes, I think. All right, so this is broken up into two parts. So we'll just look at a little bit of it just to get started on it. And Thursday we won't have such a high bar to climb. Okay. All this is building out to equations. All right. Equations just amount to solving for x and finding out what that value is. And generally speaking, what you got to do is you got to collect like terms and such, and do distributions sometimes, and then you collect your like terms, and then you put x on one side, variable on the other. I'm sorry, the variable on one side, usually x, and then on the other side you got your number. But there's two properties, and they don't mention it in here. It may mention it in those notes, but I like to find a visual for you. see. I want to find that little visual demonstration of this thing. Well, I thought I could get that bigger, but let me try one more time. All right. In dealing with equations, I guess that's as big as it's going to get. Anyway, I might be able to blow it up a bit. But the first property in dealing with equations is something called the addition property of equality. Now, what this simply means is that if you have an equation, and we're just starting out with a simple one, A is equal to B, then if we add the same number to both sides, and what they're using is C here, then that means that that equation is still equal. You know, if you've got two people that are equal to one another, and then you give them both the same thing, then they're still equal. All right. So the addition property of equality is the first property that we deal with when we're dealing with algebra. So that's why when you see people say, well, you move this to the other side and change the sign, well, that's the same thing. It's just that it's got a name. It's called the addition property of equality. There's another one called the multiplication. And it works by the same principle. I could have used. Okay, so here we got it. Same source. There's also one called the multiplication property of equality, which means if we've got an equation, A is equal to B, and we multiply both sides, well, they darn left it out. It should be a dot C right there. Anyway. Let's look at this one then. So if A is equal to B, then A times C is equal to B times C. You got two people who are equal, and then you give them 5 times as much money as they got now, well, they'll still be equal. Even though they're not exactly the same as they were before, they're both still equal. Now, with multiplication, the property of equality for multiplication, there really isn't one for division, but it's, since remember that division is multiplication by the reciprocal, then that's why this works. You know, if you divide both sides by the same value, then it essentially, you still got an equation. So let's look at this. So if we've got 7 plus x is equal to 18, then the way we solve for x in this case, and this is just going to be a one-hop thing, we're going to use the property of equality, the addition property of equality, because we don't want that 7 there. We want the x to be alone. So we're going to subtract 7 from it so that it's gone. But in order to keep this thing balanced, so it's still an equation. We also subtract 7 from the right-hand side. So 18 minus 7 is 11. And you know this is right because you can easily check it. Because if you put 11 back into your original equation in place of x, see 11 plus 7 is 18. 18 is equal to 18. So you know it's correct. All right. Let's look at another one. It probably would have been a good idea if they'd put a negative 11 here, but with the same principle is going to apply. Oh, I'm sorry. Back up, we're on number 2. Now, this is what I was saying about the multiplication property. Now, remember, division is the same thing as multiplication, so this still applies here. 7x is equal to negative 14. If we want, what we want to do to solve for x is have a single value of x. All right, so that means if we take 7 and divide it by 7, then we've got 1. Anything divided by itself is 1. But if we do it on the left-hand side, in order to isolate the x, because remember, 7 over 7 is 1, so we just got the x. We got to do it on the right-hand side. So negative 14 divided by 7 is negative 2. And again, they're showing you that it checks out by going back to the original equation and putting negative 2 in place of x. 2 times negative 2 is negative 14. Negative 14 is equal to negative 14. Bingo, we got what we need. So we found 2 solutions, one by using the addition property, one using the multiplication property. We'll come back to these on Thursday when we revisit this. All right, so let's see. Probably just got time to go over one row of things here. All right, so why don't y'all give a hand on 1 through 4, or give a try. All right, anybody come up with an answer on 1 yet?
X equals negative 3.
Oh, number 1? All right, now you can check it. If you think that's right, what happens if you put negative 3 in place of x there? Negative 3 and negative 6 is what?
Negative 9.
Yeah, so you know it's not right. So try it again. What happened on that one? Did anybody else come up with an answer?
8.
8, right? All right. Then they got to throw a z in there. I always hate z's because my z's are real easy to turn into 2's. Anything happen on number 2 yet?
6.
6.
All right, that sounds good. All right, 3 and 4. Anybody got those?
3 is negative.
Negative what? 10?
Yeah.
And then what about the last one?
2.
I do believe that's right. Let's go over to the board. I guess I just got to clear this. I don't think there's any more. All right. So the instructions here are just solve for the given variable. You can't really say X because they got a Z in there, so, and a Y. All right, so all right, so let's hack out these two here. All right, so what we're going to do for this one, in order to isolate that X, we're going to use, the only thing we can use is the addition property of quality, and we got to neutralize that -6. So what we're going to do is use the power of that addition property and add the opposite. So what we're going to do is +6. But if we do it over there, we got to do it over here. Eight. And then you can check it to see. An awful lot of math, algebra, you don't really need someone to tell you it's right because you can usually check. See, so what we're going to do is put 8 in place of X, and that will tell us if it's right. 8 minus 6 is 2. So that one checks out. That's a check mark, by the way. Doesn't look very good, but. So that one's right. All right, so here, the Z is to be isolated. We're going to add the 11 to both sides. So Z is equal to 6, right? And then when we check, six minus 11, -5. So 6 take away 11 is -5. I'm gonna just hammer out these other two real quick. I don't know. Does anybody know what time we're supposed to get out? Is it 11? Is it? It's 4:35 or 4:45?
4:35.
35.
Okay, well we can go then. All right. I don't know. I've got it's odd times, and I've got one class that for some reason it starts at 9:30 and then it says out at 11:50, and I don't get it. Which this one starts at 2:30 and it gets out at 4:35, so it's confusing. All right. I don't know if these are too short or that other one's too long. I think it's that one is a little too long. All right, so I'll see you Thursday. Get as much of this done as you can in the homework. Bring any questions you got. We'll continue on from there, from here.
Thank you. See you